Hello friends, so we have come back for the remaining formulas of trigonometric functions. The sign of minus theta is nothing but minus sine theta. Cos of minus theta is cos theta. Tan of minus theta is minus tan theta. Here you can note that the minus sign which is there inside the sine function comes outside the sine function. In cos of minus theta, the minus sign which is inside the cos function disappears in the right side, and tan of minus theta, the minus sign in the tan function comes outside the tan function. So you can see that the cosine of minus theta, the minus sign merges, okay, or disappear, yeah, on the right side. So, and in the similar manner you can get the sec of minus theta is nothing but sec theta. There also the minus sign disappears, and for remaining both, that is cot of minus theta and cosec of minus theta, the minus sign will come outside the those ratios or functions. Now we will start with the next set of formulae known as the expansion or defactorization formulae. The expansion or defactorization formulae, the arrow you can see which is from right to left means that the formulas are applied from right to left, but while reading it we will read it from the way we have written it, the sign of a plus b plus sign of a minus b. Now since this is the first compound angle formula, this is the second compound angle formula, you know the right side of first compound angle formula and the second compound angle, right side of second compound angle formula, you can add the two, and we get that 2 times sin A cos B, that is which is a first term of the both the compound angle formulae. For a sine of A plus B or sine of A minus B, we assume the sine of first angle multiplied by cos of second angle first, and that becomes twice, and the other term gets cancelled while adding. In the same manner, when we subtract the same formula, we will get the second term gets added twice, whereas the first term get cancelled. So twice of cosine of the first angle multiplied by sine of second angle we are getting. The third one is cos of A plus B plus cos of A minus B, where we know that for cosine of compound angle formula, we find the cosine ratios first, minus, for plus it becomes minus, the sine ratios of both the angles in the next term. So here you get that when we add that those two formulas, the twice of the first term appears on the right side, that is cosine of both the angles, and when we subtract the two compound angle formulae, we get the twice of the second term. Now the second term in both the formulae is minus sin A sin B, and that gets twice, that is it gets double up, that is minus of 2 times sin A sin B. So if you check the formulas on the other side, only the last formula is there for which we get the sign is minus, otherwise it is just a double of the. So you can remember this, that it is nothing but for addition, the twice of the first term of the compound angle formula, and when it is subtraction, it is the twice of the second term of the compound angle formula. So ultimately what I get is sine of a plus b plus sine of a minus b is 2 times sine a cos b. Sine of a plus b minus sine of a minus b is 2 times cos a sine b. Cos of a plus b plus cos of a minus b is 2 times cos a cos b. And cos of a plus b minus cos of a minus b is minus 2 times sine a sine b. Now, the thing is that these formulas are used from right to left. Why it is so? That on the right you can see only A, only B. The values of only A and only B will be there, and when you apply the formula from right to left, for to right left, it becomes easy because you know the single A, single B, so you can find out A plus B, you can find out A minus B. Okay, and that is why these formulas are applied from right to left. One more thing is that we are calling them as an expansion formula or defactorization formula. Why we are calling so is that, note that on the right hand side you can see the products. Those are the all are expressed in terms of product, whereas on left hand side we are getting the addition or subtraction. So the product gets converted into the sum or difference, and that is why also it is known as the expansion formula. It gets converted, the product gets converted into number of terms, the two terms which we are getting. Okay, so that is the expansion or the defactorization formula about those formulas. Now we will go to the factorization formula. Now factorization formulae are applied from left to right, and we will see one by one. But before starting those formulas, just see that a plus b is written as c, a minus b is written as d. So what happens that the same formula we are writing here, you can note that a plus b, instead of a plus b we are writing c. So this becomes sin c plus sin d, sin c minus sin d, cos c plus cos d, cos c minus cos d. Okay, and on the left side, right side, the right side also you can see the same thing, that 2 times sin into cos, cos into sin, cos into cos, and sin into sin with minus sign. So everything is same, only the thing is that in place of A we are writing C plus D by 2, and in place of B we are writing C minus D by 2. And why we are doing so is that, see that already we have this relation, a plus b is equals to c, a minus b is equals to d. So when I add these two simultaneous equations you solve for, you get that a is nothing but c plus d upon 2, whereas b is nothing but c minus d. So that minus a will get cancelled, giving you c minus d upon 2 as cosine ratio, the angle B. And so the same thing we have written in the factorization formula. So in terms of C and D, and now we are going to apply them from left to right. See that on left I know the value of C exactly, what is value of D exactly, so that I am able to find out on right hand side what it will be, the C plus D upon 2, and what will be C minus D upon 2. And that is why these formulas are used only from left to right. Now why we are calling them as a factorization, because you can see that on the left side you see that it is in the sum or difference, the terms, the two terms are there, that is that the number of terms are there more than one. And on the right side when we apply it, the right side which we are getting is the in terms of the product. That is, those are the factors, and that is why these particular formulas are known as factorization formulae. Okay. Now, in the similar manner, we are going to now discuss the factorization and expansion formulae, but the same, not the same factorization and expansion formula we are repeating. Why? Because at the same time they are nothing but half angle and double angle also. So with the help of those half angle and double angle formulae, we are arriving at those formulas. We will just check out what we are getting, and the arrows are also shown to you, that from left to right when we use, they are the factorization formulae, at the same time they are half angle formulae. So we are converting the angles into half angles, and at the same time we are converting the addition subtraction into the product form. Whereas here from right to left when we are using, they are known as expansion formulae. This means that the product will get convert into expansion, sum or difference, whereas the formulae from right to left when we are using, they are nothing but the double angles. We come into the double angles. Okay, so just see that 1 plus cos 2 theta is 2 cos square theta. Let me tell you that cos 2 theta is 2 cos square theta minus 1. Cos 2 theta is equals to 2 cos square theta minus 1. We are bringing that minus 1 on the other side, becomes 1 plus cos 2 theta equals to 2 cos square theta. Okay. In the same manner, using this second formula, cos 2 theta is 1 minus 2 sin square theta. Minus 2 sin square theta, when you take it on the left side, becomes plus 2 sin square theta, and at the same time we bring this cos 2 theta from left to right, becomes minus. So 1 minus cos 2 theta is equals to 2 sin square theta. So these are the half angle formulae, and with the help of this half angle formulae, we are just modifying them, and what we are getting is that from left to right when we are using it, the sum or the difference gets converted into product form, square, 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 square. So it gets converted into product form, and that is why known as factorization formula. Whereas expansion formula, when we use them from right to left, that is right to left, when I look at, the product gets converted into sum, the product gets converted into sum, the product gets converted into minus difference, the product gets converted into difference. So that is why they are also known as expansion formula when we apply from right to left. Now these two formulae are nothing but the modified formula from this, and you can always check out the cos theta plus sin theta the whole square. Now you know that a plus b the whole square is a square. So cos square theta plus sin square theta b square. So cos square theta plus sin square theta is the identity, and that is why we get 1 here, and plus in between 2 cos theta into sin theta, which is nothing but, you can check that it is 2 sin theta cos theta which is there, and when we convert it from right to left when we apply, it is nothing but sin 2 theta. So it becomes double angle, and it is nothing but the the product gets converted into sum. In the similar manner, when you open this bracket, you can check that we are getting minus sign here, because the middle term will be minus 2 times AB, that is minus 2 times sin theta cos theta, and which is nothing but sin 2 theta. Okay, so this is how we are getting the factorization or expansion with along with the half or double angle formulae. Now one more part is left with us. The angles are known as allied angles. Now allied angles, what do you mean by those allied angles is that the allied angles, let us say A is the angle, and when the angle is expressed it as n times, n is the natural number, times pi by 2 radians, that is 90 degree. So when the this angle is expressed as the multiple of 90 degree with plus or minus some remaining number angle, where that angle will lie in between 0 to pi by 2, that is 90 degree, that is the acute angle. When it is the acute angle, then if we are able to express, now any angle can be expressed like this, the multiple of 90 degree or multiple of pi by 2 plus or minus theta. Okay. Now after expressing this, now if I want to find out the trigonometric functions of given allied angles, how to find them is that we make use of this rule ASTC. The A stands for all ratios, that is the basic ratios we are talking about, sine ratio, cos ratio along with the tan ratio. Okay. Now the three ratios I am talking about, the reciprocal will behave in the same manner. All ratios are positive in the first quadrant. Sine ratio, hence the reciprocal of sine ratio, which is cosec ratio, is positive in the second quadrant. Tan ratio, hence the reciprocal of tan ratio, which is cot ratio, is positive in the third quadrant. Then cos ratio, hence the reciprocal of cos ratio, which is sec ratio, is positive in the fourth quadrant. And so with the help of this, see that what is the measure is given to you. You can always check where the terminal arm of this given allied angle lies. Accordingly, use this rule ASTC and write the answer, whether it is a plus or whether it is minus. Okay. And then, for example, if I ask you the angle is say 260 degrees. The angle 260 degrees can be written as 270 degrees, which is 3 times 90 degree. 3 times 90 degree minus 10 degrees. So what happens that this theta becomes acute angle 10 degrees. Okay. Now the positioning of 260 degree is in the third quadrant, right? And because we are always considering that it is an initial arm lies on the positive x-axis with vertex at origin. So 260 degree angle is lying in the third quadrant. In third quadrant, the tan ratio is positive, the cot ratio is positive. But if they ask me what is cos of 260 degrees, I want to find out, then I can always write that the 260 cos of 260 degrees is 3 times 90 degrees minus 10 degrees. And now the cos of 260 degrees, since 260 is lying in third quadrant, cos ratio is negative. So I write minus sign, I assign the sign there, and then I go to the n. Now the number I said was 3 times, so it is odd. If it is odd, use this rule that sine will change to cos, cos will change to sine. Now just now I said cos of 260, so cos will change to sine. So I will write minus, because the 260 is lying in this quadrant where cos is negative, minus sine, because of n is odd, sine 10 degrees will be the answer. The tan changes to cot, cot changes to tan, sec changes to cosec, cosec changes to sec. Only when n is odd. If n happens to be even, there will be no change in the trigonometric function. So this is all about the allied angles. We will see many more examples of allied angles while solving the exercise for this particular trigonometric functions, the exercise on the depending on the allied angles. Okay, so here we will stop. We will just will remember what exactly those formulas are and how to use them. We have seen. So thank you for the to see my video, and we'll stop here.